Okay, quick and close real quick. I want to just finish up our review from yesterday, or finish up our thing we did yesterday. And we're going to just extend that very slightly today. So I'm going to do it in two parts. I want to, first of all, let's just remind ourselves what we talked about yesterday. I'll give you a chance to finish up that e-ticket, and then go through two examples where we actually solve absolute value inequalities, and then I want to give you time to work. I know that the deadline in there, I need to change it. It's not correct. I'll push it off a couple days so you have more time to finish these up. Okay. All right. So from yesterday, we were talking about taking what we knew about absolute value equations and extending that to solving absolute value inequalities. Right. So let's get on the way to make sure we get everybody. I want all Chromebooks closed. I want earbuds and phones and all that stuff away. When everybody's tension up here, we'll make this very short and sweet and get you practicing right away. So one thing we said was when we have an absolute value equation, we reminded ourselves that what's our recipe for solving that? Well, first step is to isolate the absolute value. When we've done that, whatever's in the absolute value, call it u in this case, could be anything, 3x plus 4, who knows. Whatever's inside, if it's equal to some number, then we get two solutions. What's inside is equal to the negative number, or it's equal to the positive number, and we just solve both of those and we're done, right? Okay, if we extend that though to inequalities, we have to be a little more careful because there's two different paths we can go down. If we have an isolated absolute value that's less than or equal to a number, that's going to give us a different result than if we have an isolated absolute value that's greater than a number. So let's take those one at a time. If the absolute value is less than or equal to a number, is that an in-range example from yesterday or an out-of-range example? It's an in-range, isn't it? Right? Because then we're asking ourselves, where is the distance between what's inside and 0 on a number line less than some value, right? So that's everything that's distances that are less than our maximum range, right? So the thing you want to remember then is that always goes with an and inequality. If the absolute value is less than a number, it becomes an and inequality, compound inequality, right? And the way we build that always is whatever's in the absolute value bars goes in the middle, and it's going to be greater than or equal to, in this case, the negative number, and less than or equal to the positive number. So you always write it as a three-part and inequality. Remember, this is how and compound inequalities look. They've got boundaries on both ends. They've got a lower limit and an upper limit, and we only want the values that are greater than the lower limit and less than the upper limit, right? Okay, so there's our recipe for this situation. Now, what about the other case where we have an absolute value after we isolate it that's greater than a number? Well, now we're looking for distances that are greater than our range, right? So we want distances that are either going to be bigger than positive A or less than negative A, right? That's an or situation. There's our oars on our boat. We're rowing towards the class, right? And so whatever's inside is either going to be less than the negative number, or whatever's inside is going to be greater than the positive number. When we write a compound or inequality, we always write it as two separate parts that we can solve individually. Okay, and it doesn't matter what the order is in which we take those. Okay, so would you close it up, please? Would you close it up? I want your attention up here, please. Okay, so we got these two possibilities. Now let's get a little bit of practice. So the e-ticket you guys started yesterday, it's real short and sweet. There's 5 questions that are just like this, but they're very quick. You just have to decide right away, based on the type of absolute value inequality it is, are we going to turn this into a compound and or a compound or? And then which one fits? So what's the pattern? If we have the absolute value is greater than a number, was that or and? That's or. Good, that's or. So then that would be statements 4 or 6, correct? Those are the ones that have or embedded in them. The top one's an equation. We know it's not an equation, it's an inequality, right? And so which one is it? Which one matches? 5 does. Yeah, and look what that says. Whatever's inside is going to be greater than or equal to the positive, or whatever inside is less than or equal to the negative. Does the order matter? No, doesn't make any difference. These are two separate statements. I can put either one first and either one second. It makes no difference with the or compound inequality, right? So that one would be 5. How about this one? Now I've got an absolute value, isolated absolute value is less than a number, and or. And. And how do we build the and? Whatever's in the absolute values goes in the middle, and it's going to be greater than the negative and less than the positive. So which one fits here? 2. Okay, you get the idea? And then the last 2 questions on that e-ticket are just where you have to do this kind of by yourself now. You've got to take this absolute value inequality and write it as a compound inequality. So is this going to be and or? And. Everybody agree? Yeah. Okay, it's an and because I have an absolute value that's less than a number. So let's see if we can do this here. So I'm going to write an and inequality. What do I do with the 2x plus 20? Got to go in the middle. Okay, so whatever's inside the absolute values goes in the middle. And it's going to be what? It's an and. What do you think? Okay, one thing that's true is what's inside has to be less than or equal to positive 14. What else? How about Angela, what else?
Greater or equal to negative 14.
There you go, perfect. Okay, and we got it. And that's how we'd write it. What's inside is a 2x plus 20. It's greater than or equal to the negative and less than or equal to the positive, and we're set. And then that's where we're stopping in the e-ticket, but what we'll come back and do here in 10 minutes or so is just take into account the stuff we already sort of know how to do and are probably still practicing a little bit, but how do we actually get to the finish line on this and solve for x? You know, solve the inequality. One more, and I'm going to let you work. How about this one? What's this? This is going to be or. It's going to be or, isn't it? Good. So now whatever's inside, what has to be true of whatever's inside? It's got to be greater than 24, or, very good, or whatever's inside is going to be, I heard it, it's going to be less than the negative. So there are my 2 inequalities that I'd write. Doesn't matter the order, right? Make sense? Yeah. Okay, go. We'll give you a chance to finish that up. Back to it. Okay, so let's look at 2 examples now where we solve the entire, we're going to go all the way to the finish line. We're going to solve the absolute value inequality. So what are we going to do here? First step. Isolate the absolute value. Good. So the first thing we want to do is we're going to isolate the absolute value. So this part right here, we're going to isolate it. What are the steps we go through to accomplish that? First thing, what we'd have to do. Okay. If I'm going to get that by itself, what's the first thing I got to do? Okay, what's that mean? In this case. I can't do that because the negative 4 is being multiplied, right? Add 1, good, right? Because and think about why we're doing that. This is just reversing order of operations, isn't it? If we're trying to isolate something like this, we're going to first of all undo any addition or subtraction. So we want to add 1 to both sides, right? To get rid of that term. Okay, good. So we add 1. So that takes care of that step. And that gives us negative 4 times absolute value of x plus 9 is less than or equal to what? What's negative 21 plus 1? Negative 20, good. And then what?
Divide by -4.
Okay, good. Divide each side through by -4, so there's our multiply divide. And that did the trick. Right now, we've got the absolute value of x plus 9 is less than, I gotta flip it, don't I? Right? Because I'm dividing by negatives. I've gotta flip that. And then what is -20 divided by -4?
And then just 5.
5. There you go. Yeah, negative divided by negative is positive. Good. Okay, so there's part one. Part one was isolate the absolute value, which we did. Okay, now part two is what we've been practicing, right? What do we do with part two? Yeah, okay, we got to turn it into a compound, two inequalities in the form of a compound inequality. Does this become and or or? Gotta be or, right? Because we have an absolute value is greater than a number, which tells us or, okay? So now we're gonna write, part two is write as compound inequality. And so what's inside is gonna be what? Greater than or equal to 5, good. Okay, and that's an or, right? So we need an or. X plus 9 is? Good. So what was inside is either greater than or equal to the positive, or it's less than or equal to the negative. So there's part two. We wrote it as a compound inequality, and now is the easy stuff. Now we just solve the inequalities. There's only one step to solve each of these. What's the one step to get the x by itself? Yeah, we just subtract 9. Which gives us, on this side I get x, on this side I get 5 plus -9, or 5 minus 9? -4, good. Or, how about over here? I'm going to subtract 9, which gives me x is less than or equal to -14. Good, so there's our answer. Now, how would I write that with, let's write that using interval notation. So how would I say x is greater than or equal to -4? Bracket, good. Good. Okay, and how about x is less than or equal to -14? -14 bracket, and we got to use the union in between, right? And so that just matches what we'd see on the number line. If we graph this thing on a number line, interval notation matches exactly what we see, right? We'd end up with down here at -14 and at -4, we'd end up with closed circle, shade to the left, closed circle at -4, shade to the right. Okay. All right, last one. And you're just working. So what about this one? What are we going to do first? Add 1. Times the absolute value of 3x plus 9 is less than 6. Good. And then, good. Okay. And we got there. Now we isolated the absolute value. So the absolute value of 3x plus 9 is less than what, 3? Okay, so now we're going to convert, right, to a compound inequality. What's this one become? Okay. Or and, which one's going to be? And, good. Good. So mix inside. For and goes in the middle, and it's greater than the negative and less than the positive. Okay, so there's our compound inequality. Now all we have to do is solve. Okay? So to solve that, what do we do? Subtract 9 from everything. Good. So that's going to give us 3x in the middle. Negative 3 minus 9 is negative 12. 3 minus 9, negative 6. And then finally, we divide everything by 3. That's going to give us x in the middle, which is what we wanted. We isolated the x. There it is, right? X is greater than negative 4 and less than negative 2. Now, what if I wrote that using interval notation? It's really easy, isn't it? And how come parentheses?
Because it's not equal
There's no equal to. Okay, does that make sense? Okay, we're good? Got it? Practice.